Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to calculate permutations and calculations with a hand calculator and then provides practice in using them to calculate probabilities. Let's get started. So I'm going to use the model that I recommended for this course to demonstrate how to calculate the things that we've talked about so far with the hand calculator. If you have a different model, it's probably similar to the way that I'm going to show you here with this model. You'll have to check the instructions for your particular model of calculator to see exactly how to do it. But I would imagine it would be similar to what we're looking at here. So how do we calculate combinations, permutations, and factorials with the calculator? The first thing we need to look at is finding those functionalities on the calculator itself. So if you look at what we're pointing at here with the blue arrows, notice we've got the NCR, the NPR, and the X factorial. So these are the functionalities that we need. And because they're listed above the button, they're what's called a secondary function on the calculator. So in order to activate the secondary function, we're going to need to press that second button there on the calculator. So the way this works is, if you want to calculate, say, a combination where you've got 12 items and you're selecting them 6 at a time, you're going to press the 12 because you got 12 items total. So enter 12 in the calculator. And then you're going to look at pressing that second button and then press the NCR, so that's the 8. And then you're going to enter in the 6 because you're choosing them 6 at a time. So enter in 6 and then press equals. And then voila, the calculator does all the calculation for you. It's a little different with the factorial. So if you're calculating, say, 4 factorial, you're going to press 4 because you want 4 factorial. And then you're going to press the second button, press the 3 to get the factorial function that's right above it. And then you're going to press equals, and out comes 24, which is 4 factorial. So learning how to access the functionality that's in your hand calculator can be very, very useful. So you don't have to use those, factorial equations that we were looking at earlier for calculating all this stuff. Now, if you want to use Excel, there it is. You're more than welcome to use it. Here's the functions you need with the syntax so that Excel can calculate this stuff for you. So you're just going to type in an equation in a cell, and you're going to replace N and R with the respective values. And then when you hit equals to enter that equation into the cell, Excel will calculate that function for you. So either way you want to do it, learning how to get a computer of some kind to calculate this for you is really to your advantage. Let's look at an example problem to practice what we've learned so far about calculating the whole part for a probability. So here we've got somebody who's stealing credit card statements from a garbage can. So the thief is obviously planning to try to use somebody else's credit card account to make some purchases. But the thief has just the statement. In order to authorize the purchase, the thief is going to need the authorization code, which appears only on the back of the actual credit card. So if all the thief has is the credit card statement, then, there's going to have to be a guess that's going to be made on the authorization code in order for this plan to work out. So how many possible codes does the thief have to choose from? Well, it depends on what credit card you got, right? If you've got a MasterCard or a Visa, the authorization code is 3 digits and appears on the back of the card. If, however, you have an American Express card, the authorization code is 4 numbers and appears on the front of the card. So just for grins, let's just say that we're going to use a MasterCard or a Visa, so we've only got 3 numbers to choose from. So now the question we're going to ask, the first question is the order important? Well, what do you think? Is the order important? Well, the order is important, okay? But each of the digits that you're choosing are from the same group of 10. And you can have repetitions. They're allowed, okay? So what we're really looking at here is not permutations or combinations. This is an example of using that fundamental counting rule that we talked about earlier. So here's how we set up our calculation. So the first number that we're selecting, there's 10 possible digits to choose from. The second digit that we choose, there's 10 possible digits to choose from. And the third digit that we're choosing, there's 10 possibilities to choose from. So we're just basically multiplying these by each other, because what are we doing? We have to select the first number correctly, and we have to select the second number correctly, and we have to select the third number correctly. So the total number that we have here is 10 to the third, which is the same as 1,000. So there are 1,000 different codes that you can choose from. And you're only going to make, there's only one correct guess, so the probability of guessing the correct code on the first try, come on, you got this. You got this. What is it? I hope you just said 1 over 1,000. That's what it is. So that's 1/10 of 1% chance of correcting the code. You're getting that code correct on the first try. Now, between you and me, I think that's too high of a probability. I mean, seriously. I don't want somebody to just be able to guess the code and then use my credit card account, okay? So what I'm going to do is I'm actually going to shred the credit card statements that I throw out, okay? And then it becomes even harder for the thief to do what the thief wants to do, because not only do you not have the authorization code, but now you don't even have the number, man. You got to kind of piece this stuff together, okay? Of course, if you really want real security, you'll just go a step further than shredding. You'll burn the actual statement, okay? So all you've got is ash. But, that's if I don't think you need to go that far. I think you're a little paranoid if you want to go that far. But yeah, so you can see the probability of guessing, it's not that great. Let's look at an example involving corporate officers. So we got a corporation that needs to appoint a president, a CEO, and a CFO. And it also needs to appoint a planning committee with 3 different members. So there's 10 different candidates that are all qualified that we have to choose from. And people who are selected as officers can also serve on the committee. So how many different ways can the officers be appointed? Well, what's the first question we ask? Is the order important? Well, what say you? Is the order important when you're choosing the officers? And you should be answering, yes, it is important, because there's a hierarchy here, right? Okay? Some people are over other people. So you've got a structure here where order is important. So yes, the order matters. That means we're going to calculate the sample space using permutations. Okay? So there's our permutation equation. We're actually going to punch this out on our calculator, like I showed you just a moment ago. And there's 10 different candidates. We're choosing 3 of them. So when we punch that out on our calculator, we get 720. How many different ways can the committee be appointed? Well, again, we asked, is the order important? Well, for the committee, the order is not important. There's no hierarchy within the committee. If you're on the committee, you're just on the committee, okay? So there's no order within the committee. So that means order is not important. So now we're going to calculate using combinations. Again, we use the same numbers, the 10 and the 3, and out comes 120. You can see you're always going to have fewer combinations than permutations for the same problem. Now, what's the probability of randomly selecting the 3 youngest candidates to serve on the committee? Well, that's going to be the committee, okay? So the whole that we're using comes from the combination calculation. And there's only one possible combination, that's the 3 youngest. So the part is going to be 1, and the whole is going to be 120. So there's our calculation right there. If we want, we can actually calculate that out. But, just do whatever your problem asks you to put in for the answer field. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.